Okay, so I'll be going over problem 2. Basically, in this problem, Sanjay has K guests over for a party, and then he has to buy some cookies, such that the quantity of cookies he buys is a power of 10, and then he wants to find the smallest power of 10, such that he can evenly distribute his cookies to his K guests. So basically, find the smallest integer x such that 10 to the x is divisible by K, or for that none exists. So for example, like for 20, 10 to the second is the smallest power of 10 divisible by 20. There's no power of 10 divisible by 60. Okay, so basically, this problem, let's basically restate the problem. So we want 10 to the x divided by k to be equal to some integer, because because that's just the definition of being divisible. Since the x is divisible by k, then the resulting fraction will reduce to some integer. So in order for this to reduce, we know that everything in k must cancel out with something from the numerator, right? In order for the final denominator of the fraction to be 1, so then the resulting fraction would be like an integer over 1, which is just an integer. So to do this, we want to like think about the prime factorizations of the numerator and denominator to see like what can be like canceled out. So 10 can be changed into its prime factors 2 and 5. So we can rewrite 10 to the x as 2 to the x times 5 to the x, and then k will just keep at k for now. So this again still has to equal some int, right? So we see that here, if k has any prime factors other than 2 or 5, then this will be impossible, right? Because like say k has a 3 in it, and its prime factorization, then that means that it will never be able to be canceled out with something from the numerator. So we'll definitely end up with that 3 or other prime factor in the denominator, and then this will never be able to be an int. So after that case, we'll think about if 2 and 5 are the only prime factors in k, right? So let's say we have something like an example is like 2 to the x, 5 to the x, and then k is like 2 to the 3 times 5 to the 9. Okay, then we want to know the smallest x that can reduce the entire fraction, right? So here, like it's like kind of clear that you want like the smallest x that can cancel everything out. It will be the maximum of these two exponents. So in this case, the minimum x that will cancel everything out is 9, right? Like if you have something like 8, then like there will be an extra 5 that's still left in the denominator that you can't cancel out. And yeah, so that's why the maximum of these two exponents will just be the minimum x possible. Okay, so now let's start coding the solution. Okay. Basically, the only input is k, and k is quite large, so we have to store in the long. So here, all we're gonna do is we're basically gonna extract all the exponents of 2 and all the exponents of 5 in the prime factorization of k. So we're basically gonna make two variables, where like 2 will be the exponent of 2 in the prime factorization of k. So in this case, 2 you want to end up as 3, and you want the variable 5 to end up as 9. So basically, how this is going to work is while there's still a factor of 2 remaining in k, then you will divide k by 2 and increment your count of the exponent. And you do the exact same thing for 5. Basically, what these two loops do is extract all the factors, like all the exponents of 2 and then all the exponents of 5. And then now, if after we've extracted all the 2s and 5s, there's still like something left in k, then that means that it's impossible, because there's some other prime factor there that we can't cancel out, and otherwise we can just print the maximum of the two exponents. So let's see if this works. Okay. So one other like possible solution to this problem is if you can just try to construct all the powers of 10. So like you can start at 1 and then like keep multiplying by 10 and then check if your current power of 10 is divisible by k. So how that will work is like one thing you have to be careful about if you try to do that solution is you have to think about what the maximum, like what the highest power of 10 that you might need to consider is, right? Because then you would go up to a certain like very high power of 10, and then if none of those are possible, then you would print -1, right? So if we look at what the highest possible x we might have to consider is, we see that so this is 10 to the 18th k, which is about like the size of a long, which has 64 bits. So like that means like k can be about 2 to the 64 or like 2 to the 60 or something. So that means that like maximum x could be like 60. So that clearly would not fit, like 10 to the 60 would not fit in a long. So you would have to use like a big integer if you're coding in Java or C++, or like if you're in Python, you don't have to because it just already stores it pretty much like that. Yeah, so that's just like one detail you would have to make sure you got right if you did that solution. So does anyone have questions? All right, okay. So that's the end of today's